So now that you know a little bit about what the ManagedBlocker interface looks like and some of the semantics, let's talk about how you might apply it. And we're going to show a couple of different examples of applying the ManagedBlocker to work with blocking synchronizers and blocking queues. Keep in mind, those are not the only use cases that are relevant. There's also I/O operations as well. So these examples come straight out of the Java documentation on ManagedBlocker, but the documentation doesn't walk through the examples line by line like I'm about to and provide more context, which I'm also about to do. So if you go here and take a look at this interface documentation, you'll see these examples. So the first example here has something called a ManagedBlocker, which implements ManagedBlocker. And it's going to handle a blocking synchronizer like a lock. You could use a semaphore here too. So what we're going to do is we're going to have a lock, which in this case is a reentrant lock. And this is straight out of the documentation. I probably would be tempted to make this a lock, not a reentrant lock. And that gives us more flexibility as how we could use this, but be that as it may, that's how it's done in the documentation, so I didn't want to change it. So the constructor of ManagedBlocker stashes away the parameter in the mlock field. And then what it does here is the isReleasable method is going to call tryLock to try to acquire the lock in a non-blocking way. And if we succeed, we're done because we got the lock. Now, if we're lucky, we get the lock, but if we're not lucky, the lock is locked, so tryLock will fail, and we won't actually return anything except false. So in that case, the block method does the following. It just does another little sanity check to see if the lock's already been acquired. If it has, we're done. Otherwise, we block by calling the lock method on lock, and that will wait until the lock is available. So this is why it's the ManagedBlocker class. And whenever we're done, we return true because we will have blocked until we got the resource. So here's an example that uses this particular mechanism. This is actually something that's not from the Java documentation. This is just what I wrote to show how to do this. So you might go ahead and have make yourself a new ManagedBlocker, which is going to encapsulate some kind of lock. And then you lock the lock here. And then what we do is we go ahead and we use the fork join pool common pool. That's how we get the common pool. That's the factor method to get a common pool. And then we execute the code by passing it a lambda expression that will perform a blocking lock operation. So you can see in this particular case, we say open close paren. This says it's a lambda expression arrow. That's just the syntax we need. Then we have the body of the lambda expression. And what we do here is we use a little exception utils adapter because this thing can throw an exception. And we want to make sure we capture it properly and turn it from a checked exception to a runnable or to a runnable exception and runtime exception. And then we go ahead and we call the ManagedBlock method on the fork join pool, passing in the locker. So there's the locker right there. We pass that in, that performs a blocking operation. And when we're done, we say, hey, we got the lock. You'll notice that the calling thread sleeps for basically a second and then unlocks the lock. So this is going to block for a second. And then after unlock is called, then that'll go ahead and return and acquire the lock. So let's take a look at another example. This example is also from the Java docs, which applies ManagedBlocker on a blocking queue. And this particular case is called QTaker, and you'll see why in a second. And QTaker implements ManagedBlocker as well. And the idea here is to make a ManagedBlocker implementation that handles a blocking queue. So we define ourselves a queue, which again, probably it could be an array blocking queue. It could be a list blocking queue. We just define in the field as a blocking queue. That's fine. The constructor stashes away the parameter. And then we've got an isReleasable method, which tries to do a poll call. Poll will return the element in the queue if there is one without blocking. But of course, if the queue is empty, then we will not get anything back. So we'll just get a null back. So isReleasable would return false in that case. If isReleasable returns false, then the block method will be called, and you can see what block does is it calls the take method on the blocking queue. And you probably recall from much earlier discussion in a lesson from a month or so ago, where the take method causes the calling thread to block until the item you're waiting for is available. So it could very well block. And of course, once we get take to return, we return true because we are no longer going to need to block. And we also double check if item is equal to null before we bother doing the blocking call. And then to make this work properly, we also add another method to queueTaker called getItem, and that will be called after the common fork join pool's ManagedBlock method completes in order to get the item that was obtained from the queue. And here's just a little piece of code to show how this works. So this is very similar to what we had before. We make ourselves a new queueTaker that encapsulates the queue. We go ahead and execute a lambda expression in the common fork join pool. And you can see what it does is it's going to go ahead and block until the queue has an item in it. And when it does in fact return, then we're going to go ahead and print this a diagnostic saying what item we got. This will go run in the common fork join pool. This will run in the calling thread. And in that particular case, it's going to sleep for a second and then put hello into the queue, which this will then trigger this thing to return. So that's the end of the example that shows how to apply the Java common fork join pool's ManagedBlocker interface.